This is page 2 of the notes on finding limits algebraically, which is topic 1-2 and homework 1-2. And this is example 3. Evaluate this limit. So the first step is to try to plug the number, in this case -3, in. So this turns out to be 1 over 0, which is undefined. But as we know, we have to go further when this turns out to be undefined. We go ahead and try to factor the numerator and or the denominator. So the limit as x goes to -3 of x plus 4 doesn't factor. But in the denominator, we have x and 4 and 3 and plus and plus. And then we can cancel the x plus 4s. Remember, there is still going to be a 1 in the numerator when we do that. So we have the limit as x goes to -3, 1 over x plus 3. And then we plug in -3 now that we've canceled. And we still have a problem in this particular example. This right here hasn't occurred yet, where we got undefined the first time, but then we also got undefined the second time. Okay? What we should do in that case is go on. There are 3 steps. If the second step fails, then we're really out of luck in doing it purely algebraically. We should examine generally the graph or possibly the table, but I think the graph is a little easier to interpret. So what you want to do is enter into a graphing calculator this expression and look at the graph and see what we can discern about the limit. And there it is, the graph. And now we see that, oh yeah, this function's got some issues at -3. When x equals -3, we have a vertical asymptote. The limit from the left would be -infinity, because that part of the graph goes down, down, down. The limit from the right would be +infinity. And so the limit that we're looking for, two-sided limit, does not exist. That would be the final answer to this one. Here's another one with the value of a being -2, so we want to plug that in. -2 squared minus -2 minus 6 over -2 plus 2, which is 0 over 0, and so undefined. But we need to go on, as we know, so we try to factor, in this case the numerator. And we have x and x, and we want 3 and 2 and -3 and plus 2. Then the x plus 2's are going to cancel. This will give us the limit as x goes to -2 of x minus 3 over 1. And when something is over 1 with 1 in the bottom, in the denominator, we don't need to write the 1. Now we plug in the -2, so we have -2 minus 3, which is -5. And that's our answer for this one. So that's it for this topic of finding limits algebraically. But before I wrap it up, I want to mention that this might have reminded you of something you did in pre-calculus. And that's good and that's great and that's cool if it kind of sparks something in your mind, like this is similar to something it is. What it is like, in fact, essentially the same as finding holes in rational function graphs. So I want to scoot back to the first example for just a moment and show that connection between pre-calculus finding holes and now finding these limits. So here's question 1, which we did. And we said the limit as x goes to 4 of this function. And we did some work and we got an answer of 1/6. Now in pre-calculus, you wouldn't have used the limit concept, but you would have been looking at the graph of that function, and you would have done essentially the same work. In the conclusion, the language that you'd use there is the graph as a whole at 4, 1/6. So these limits are totally related to what you did with holes in graphs of rational functions. But back then you didn't use the limit notation or concept, and now we are. If we go ahead and take a look at the graph of this function, remember our hole is at 4, 1/6. In a graphing calculator or this program, it doesn't show up. But if I can get the cursor right, click right on when x equals 4, it should with this program. So there's a hole actually in the graph right here. It's not a continuous graph right there. And, I have 3.8, 3.83. I'm getting closer and closer to 4. And when I get right to 4, there it is, see, undefined. It does sort of graph the hole if you click right on it there. And yeah, that's why the limit turns out to be 1/6, though the function is undefined when x equals 4.